Okay, hello, welcome back. This week we're going to continue on linear functions, and today is lesson 11. I don't know why there's lesson 10 here. Typo, whoops. We're almost done the Math 10C course. After this lesson, there will be one more lesson left, and then we will have covered everything you need to know. Hooray! So we're just gonna finish off our second last unit on linear functions. Today we're going to be covering general form and parallel and perpendicular lines. So before we begin, let's do a bit of review from last lesson because last lesson was quite a handful. There was a lot of new stuff coming at you. So what we first learned was a slope of a line, and that was the change in y divided by the change in x, or as most teachers like to call it, your rise over run, because your rise, which is how much it's going up by, is divided by your run, which is how much it's going to the right or left by, usually to the right. And in a linear function, so for a line, it will always be constant, which means that the slope doesn't change halfway through, like it doesn't curve or wave or something weird like that. So something else we learned last lesson was the slope-intercept form, and this was just a way to express a line in this y equals mx plus b form. And m was your slope. In French, it's moult. So that's how they say slope apparently. So that's why it's denoted by an M and not an S. And the b is your intercept, and I really don't know why they used a b as the variable, but yeah, it's just become the standard. So I guess we're stuck with that. And this form makes it really easy to find the slope and the y-intercept of the line. So that's kind of why it's called the slope-intercept form. Another form that we learned was the SlopePoint Form. And this is a linear equation written in the form y minus y1 is equal to the slope times x minus x1. So for this form, you would need coordinates from the line and the slope as well. But it does, yeah. If you were looking for a few points on the graph, then using this form would be helpful. And so here is just an overview of this unit. Slope-intercept we've learned last lesson. Point slope we've also learned last lesson. This lesson we're going to learn about standard form. In many places it's called general form, so it's interchangeable, like they're the same thing. And that's just basically ax plus by is equal to c, or yeah, we'll talk about that soon. Intercept form we don't really need to know in 10C, but it basically looks like this. I suppose it makes it really easy to find your x and y intercept, but we don't need to learn it. And vertical and horizontal, we've learned last week as well. So let's get started on some new stuff. General form, aka standard form, as you saw in the last slide, is a linear equation written in the form ax plus by plus c is equal to 0. Now, it's important to note that there are some restrictions. A, b, and c have to be integers, so you can't have something like 1.5x. And a has to be greater than 0, so you can't have something like negative 3x. And this form, it looks really weird, like it doesn't look like the other forms that we've learned so far, but it is very helpful. It does make it easy to find your x and y intercepts. So over here is just a little picture showing what each of these variables represent. The c stands for constant. The b is the coefficient of y, the a is the coefficient of x, and you will see what all of these mean in a moment. So let's give it a shot. Over here, I have an example of an equation written in general form, and we want to find the x and y intercepts of this equation. Remember, an equation written in general form, we can find the x and y intercepts relatively easily. So let's get started. Let's start off with finding the x-intercept. So for x-intercept, we substitute y equals 0, and solve. So let me highlight this. We substitute y equals 0. Okay, so let's do that. Over here we have x. We want to find what x is when y is equal to 0, right? So we substitute this for 0. And then when you have something that is 0, you can just cancel it out because 2 times 0 is 0. So this becomes 0, which means we're left with x minus 3 is equal to 0. Now it's a simple matter of bringing the 3 over to the other side by adding it to both sides, and we get x is equal to 3. So the x-intercept, we're not done here because we still have to write our final answer as a coordinate point. So when x is equal to 3, y is equal to 0. Okay, same thing for the y. When we're looking at this, I should label it. When we're looking for the y-intercept, we just do the same thing. We substitute x is equal to 0. So over here we have x is equal to 0 plus 2y minus 3. So since x is equal to 0, it's kind of irrelevant. So we can take that out, cut. And this leaves us with 2y minus 3 is equal to 0. Then we can bring the 3 over and divide both sides by 2, which gives us y is equal to 3 over 2. Once again, we're not done yet. We have to write the final answer as a coordinate point. 3 over 2. Done. This is our y-intercept. So we can always check our answer by graphing out the equation on a graphing calculator. Or on, in this case, I'll be using Desmos because I can't share my graphing calculator on the screen. So we had, what was it? X plus, was it 3y? And then I'll have to double check. X, oh, plus 2y minus 3. Okay. X plus 2y minus 3 is equal to 0. This is what our line looks like. And according to our calculations, the x-intercept was supposed to be at 3, which it is, and our y-intercept was supposed to be at 3, was it? Yeah, 3 over 2. That's equal to 1.5. So we know that we did our calculations correctly because the intercepts are there. Okay, back to our PowerPoint. Now, it's important to know how to convert between the points. So now we're gonna do a bit of practice converting between general form and a slope-intercept form. Over here, I've just abbreviated it to SI form, but it stands for slope-intercept. So over here, we have our first equation. Is this in general or slope-intercept form? Recall that slope-intercept form is written in the form y equals mx plus b. And general form is written in ax plus b x plus c is equal to 0, right? So the first equation, it follows this form, the slope-intercept form. So we want to convert this to general form. Notice how in general form, everything has been moved to one side. That's why the other side is equal to 0. So when we want to convert, we first want to move everything to one side. So right now everything is not on one side, so we have to move it over. It doesn't matter which side is 0, as long as you get everything to one side, we can work from there. So since y is isolated, let's just subtract y from both sides to move it to the right. So when we subtract y from both sides, we get 0 is equal to negative 3x minus y plus 9. Now are we done? No, not yet, because remember how in the earlier slide we had a bunch of restrictions for what our variables could and couldn't be, right? And one of them was that a had to be greater than 0. Well, in this case, a is negative. It's a -3, right? Let me highlight. A is -3, which means that it is less than 0. So we actually have to, how can we address this? Well, we can move everything to this side, thereby making a positive, or we can multiply everything by -1, which seems more reasonable. So let's do that. Multiply both sides by -1 times -1 times -1. And 0 times -1 is still 0, so that doesn't change the left side. But on the right side, all of these signs flip. So negative becomes a positive, x, and then the -y becomes positive, and the positive 9 becomes negative. So yeah, now is it in general form? Well, let's check all our restrictions again. It looks to be in general form. A, B, and C are all integers, and the A is greater than 0. So this looks correct. Let's move on. Over here, we have another equation, and this equation is written in general form. So let's convert it to SI form. Now in SI form, y is isolated to one side. So our first step is to isolate y here to one side. We can do that by bringing the 3y over. Remember, we can't just bring the y because it's attached to the 3. So we have to bring them both over and then separate the 3. Or we can separate the 3 from them first and then bring the y over, but bad math. So let's subtract 3y from both sides, which gives us 6x minus 9 is equal to -3y. Then now we just have to take out the -3 from the y, and since it's multiplying the y, we can take it out by dividing. So we divide this by 3 to get rid of the -3. And in order to make sure this equation doesn't change, we have to do it to the other side as well. So we have y is equal to -9 divided by -3 is +3. Remember, a negative divided by negative is a positive, and 9 divided by 3 is 3. And then we have 6x divided by -3, which becomes -2. And this is our final answer. Okay. Parallel and perpendicular lines. Sounds complicated, but it really isn't. So let's start off with a bit of vocab. Parallel lines have the same slope and different intercepts, while perpendicular lines have slopes that are negative reciprocals of each other. So over here, this first one is a parallel line. You see that, notice how the slopes are the same. And because the slopes are the same, these lines actually never touch. Like, they'll go that way until infinity. They'll stay apart for infinity, I guess I should say. And over here, we have a set of perpendicular lines. Now, the definition that I gave you, negative reciprocals of each other, sounds really, really wordy. But basically, what a reciprocal is, so if you had a slope, something like a over b, the perpendicular slope would be the negative, so negative, and then the reciprocal. So a reciprocal, remember, is just when you flip the numerator and the denominator. So the b is now at the top, and the a is now at the bottom. So in this case, our slope is 2, right? And then our perpendicular slope is negative 0.5. Now, it's not very obvious now because they're written in decimals, but if I convert these to fractions, so if I had 2 over 1, and I converted it, I looked for the negative reciprocal of it, then what it would turn out to be is the negative of 1 over 2, right? And that would simply be 0.5. Oh, negative 0.5, sorry. And that's what we have here. Now, I have a mini question at the bottom. So, what about lines that have the same slope and the same intercept? What would they look like? Would they be parallel? You can type any answers in the chat. Okay. Actually, this is a bit hard to answer because it's actually it's a trick question. But lines with the same slope seem to be parallel, but if they have the same intercept as well, that means, okay, let me draw out a mini diagram. If we had a line with a slope of, I don't know, 1, and it crossed the axis at 1, and we had another line with the slope of 1, and it crossed the axis at 1. Okay, wait, I'm gonna try to draw this as well as I can. Nope. Oh. Then they would essentially be the same line because they have the same slope and they're in the same place. So they would be the same line. Okay. That's parallels and perpendiculars. So over here, oh, what is this equals to 0? Oh, gotta shift it over a bit. Let's practice finding parallel lines. So I have 3 equations over here, and we want to find examples of lines that are parallel to these. So remember our criteria for parallel lines was it has to have the same slope, but different intercepts. That's a semicolon. Intercepts. Oh my gosh, you probably can't even read it. Different intercepts. Okay. So let's start off by finding the slope in the first one. Since this is written in slope-intercept form, it makes it really easy for us to tell what the slope is. It's 3/7, right? So a parallel line would have to have the same slope. And a different intercept. So it could be anything but 4. Well, you probably can't even see this yellow very well. So we can choose any intercept but 4, which means we can choose something like, I don't know, 5 or 3.4 or pi. Those would all not be the same line as 4. So there are actually there are infinitely many parallel lines. Okay, next up we have y is equal to 7. Now this one's less obvious, but if you remember from last lesson, this would actually be a horizontal line, because if you imagine that there was actually a y is equal to 0x plus 7, so a slope of 0, which means that the line never rose any, then it would just be taken out because it's kind of redundant to write 0x in there. So yeah, this is a horizontal line. So what is the line that is parallel? Well, if you had a horizontal line at 7, then any other, like you could draw a line anywhere else that was horizontal and it wouldn't touch the line at 7. So we could pick any random number, like y is equal to 100 or something. It really doesn't matter. There are infinitely many. Okay, next up we have an equation written in general form. Now here's where it gets a bit trickier because we don't know what the slope is. So let's convert it to slope-intercept form so we can more easily find out what the slope is. So I'm going to start by moving the y to the other side. And then because I have to get rid of this coefficient, the coefficient, by the way, is -1. It's not obvious, but the negative sign denotes that it's -1. So what I'm going to do is multiply both sides by -1. This gives me -3x plus 5 is equal to y. So now we can more obviously see what the slope and intercept are. The slope, the slope, or let's start off with, I'll highlight the slope and intercepts. Oh my gosh, so many colors. The slope is -3, so we can make an equation that has a slope of -3, and we can find some random intercept like 50. It really doesn't matter. We can even go into the negatives. But yeah, that's it for parallel lines. Now for perpendicular lines, similar idea, except for the perpendicular lines, we don't need to worry about intercepts. We just need to find the slope. So let's start looking for slopes. Over here, we have an equation written in general form. So once again, we need to convert it to slope-intercept form to more easily find the slope. So let's isolate y first by moving y to the other side. Equals -4y, and then we get rid of the coefficient by dividing both sides by -4. Bam. And we get 5/4. Oh, -5/4. Next, minus 20 divided by 4 is 5. So now that we have our slope, which is -5/4, we can find our perpendicular slope. Remember, we need to look for the negative reciprocal. So first of all, negative of -5/4 would be +5/4. And then the reciprocal of that would be 4/5. The reciprocal. This is the reciprocal slope, and then we just add in the rest of the equation. Okay, that's it. Also, it doesn't matter where your y-intercept is. It can be anything. But if your slope is the negative reciprocal, it'll still intersect your line somewhere. Okay, now we have something else. Y is equal to -x plus 9. Is this written in slope-intercept form? Hint, hint. Okay, I'm just gonna say it. Yes, it is. Even though there's no it doesn't seem like there's a coefficient index, there actually is, because that negative sign over here is denoting that there is a coefficient of -1. So, yeah, that's our slope, -1. Is equal to -1. So the negative reciprocal would be 1. In case I need to go through the details, so let's write this slope in fraction form. We have -1/1. If we want to find the negative reciprocal, we just flip 1/1, which still turns out to be 1 and 1, and we get the negative of a negative, which would be positive. Yeah, okay. Now we just write it out. Y is equal to x plus anything. 100 again. Okay, we're almost done. This is the last slide. Here's a word problem for us to go through. So, triangle ABC has vertices A, B, and C. So we want to write the equation of the line containing the altitude of point B to side A. Now, this is quite wordy and hard to wrap your head around. So what I find helps is drawing it out. That's why I included a Cartesian plane here. So let's try plotting all these points. So first we have A at -3 and 5. So 1, 2, 3, and then 1, 2, 3, 4, 5 is here. Oops, I should make the marker darker. We have 3, 5 here. And this would be A. And then we have B at 4, 7. 1, 2, 3, 4, and 7. And then we have C, which is at 4 and -2. 1, 2, 3, 4, -2. C. Okay, so here are all our points, and it's a triangle, right? So let's connect it. I'm going to try my best to draw a straight line. Okay, it's getting there. Ooh. Hey, that wasn't so bad. So here's our triangle. Obviously, it's not the best. I didn't use a ruler or anything, but we want to find the altitude. What the altitude is, so let me kind of draw one out here. The altitude would be the point from one end to the other end that forms two right triangles. So in this case, we want to find the altitude from point B, which is this, to the side AC, which is this. So our altitude would be something around here, right? And so we would form a right triangle, or a right angle, I mean. And we want to find the equation of this line, Whoop. Okay, so let's start. What do we do? Well, it's helpful to see what we're working with. So over here, we're given points, right? So if we're given points and we're given points, which form could we use to solve the equation? So we're only given the points of A, B, and C. We're not given the y-intercept or anything, so we don't know what that is. So we will have to use the point slope form to find, let me grab a blank slide so we can do some calculations. We'll need to use the point slope form to find the slope of this line. Then using the perpendicular, finding the perpendicular slope. Wow, I'm so articulate today. Then finding the perpendicular slope, we could find out the equation of this, the altitude. You might be wondering, well, why can't we just use the point slope form to find the altitude? Well, that's because when we use point slope form, we actually need 2 points. And if we were going to go directly to calculate the altitude, we don't have 2 points. We only have one, which is B. But in the case of this side, we do actually have 2 points because we have A and B. So, I just got a notification. So we can find out this equation and then find the perpendicular to find this equation. So let's get started. Let's start off with finding the equation for side AC. I'll label it out. Equation of AC line. It's helpful to label things. Keeps your work organized. We can use, what was it? Point slope form, right? And if you recall from last lesson, point slope form is y minus y1 is equal to m, which is our slope, times x minus x1. So, what can we do? Well, since we're given the information for the points, we can substitute the points into our equation, right? So y1 was, I have to squint to see. Okay, I'm just gonna move slides. We can use A and C, right? So let's use A as the first point and C as the second point. So A is -3 and 5, and C is 4 and -2. Okay, I'm gonna copy this down. I'm gonna forget it. A equal to, what was it? -3 and 5. And C was 4 and -2. Okay, double check. Yep. All right, so let's sub those points in. y2, let's use c. So we have -2, which is this, and minus y1, which is 5, that's equal to m, which we don't know, times x2, which is 4, minus -3. Okay, now let's do some calculations. -2 minus 5, what's that? Well, negative minus negative is an even more negative, which becomes -7. The slope, we don't know, but in the brackets, we can calculate 4 minus -3. Negative minus a negative is positive, so it's really 4 plus 3, so it becomes 7. And then, yay, we can divide both sides by the coefficient of m to isolate m, and that gives us -1. All right, we found our m, but this is not the final answer, because what we're looking for is not the slope of this, but it's the slope of this. So we can, let me grab another slide. We can find the perpendicular, perp, of, oh, that's a bad title. Now we can find the equation of the altitude, right? And to do so, we just need to find the perpendicular of our AC line. M is equal to, what was it, -1? And the perpendicular would just be +1. And this would be our slope, but we have to write it out as a full equation. So let's do that. It's up to you what form you want to write it as, but since we don't really know the y-intercept, we could calculate it, but why bother? Then we're stuck with point slope form. So let's just use that. So point slope form was the form y minus y1. Let's just use a as our point. So y1 in that case would be 5 is equal to the slope, which is 1, times x minus, what was our a value? Is it -3? Awesome. We're done. Actually, technically, oops, dropped my pen. Technically, you don't need to include this 1, because 1 when it's, oops, 1 when it's not, when it's the coefficient is considered redundant to write, so we can actually just cross it out. And this is our final equation. Yay! Yeah, that's it for today's lesson. So it was a pretty short one. So just to review, today we learned about the general form, and we learned about parallel and perpendicular lines, and we also did a word problem. If you want more practice or you want more challenging questions, then feel free to take a look at the workbook, do some of those. Yeah, feel free to reach out if you're having trouble with some of the questions there. Our educators would be happy to help. And just a reminder, tomorrow's our last lesson. Oh my gosh. Yeah, we've made it through this far. We're almost done. Hope you've enjoyed this course with us. I've certainly enjoyed teaching it. So yeah, see you all next week. And good luck. Have a good weekend.